So metallic character, it is the degree of metal character in an element of an element. Now, when you see in the periodic table, there are left side more metals and right side non-metals. So when you talk about metallic trend, we can say metallic character decreases from left to right across a period and from bottom to top in a group. So this trend is the similar as atomic radius. In a periodic table, left side below the zigzag line there are metals, okay, and above the zigzag line there are non-metals. So that's why when you go from left to right across the period, it decreases. Okay. Now let's see properties of elements. Says the properties of the elements follow regular pattern we can predict unknown properties of elements based on what we know, right? So we can always predict. And when you look at in table 5.2, it lists several properties of alkali metal except francium. So we can predict properties of francium. So we can, let's say, when you look at table 5.2, it lists several properties. Of alkali metals except francium, and then based on that we can predict properties of francium. So based on this pattern we can predict properties of francium. francium. So let me draw this table, so 5.2, and that way you can find out the properties of francium. So let me give you an example. I'm going to draw a table. Let's say we have element, we have atomic radius, we have its density, gram per milliliter, melting point, and its atomic mass. These properties are given for certain elements, for example, lithium, sodium, potassium, rubidium, and cesium. So when you have that, let's say 152.186.227.248 and then 0.266, and then the density is in gram per milliliter. I'm writing it, table 5.2. So let's say so and so forth. So when we predict francium, alright, francium is here. We know that in that column francium is here. So we can predict radius. It should be greater than 0.266, right? We can predict based on that trend. We know that when you go down, atomic radius increases. Then we can say density is also greater than 1.87. Now let's say about melting point. Here I'm going to write 180.5, 97.8, 63.3, 38.9, 28.4, and that's going to be degrees Celsius. In this one we can say melting point should be other way around, less than 28.4. And atomic mass, we know that, right? Atomic mass, looking at the periodic table, 6.94, 22.99, 39.10, 85.47, and it's 132.91. So based on this, we can say, okay, we can predict that. Okay? So you can predict what's there. If we know the trends, then we can definitely predict. So now let's talk about members of the family. Members of a family also have similar chemical properties. Now we are talking about chemical properties before we talk about physical properties.
Family is another name for group, right?
Mm-hmm.
Okay.
Yeah. So now all alkali metals, all of the alkali metals have oxides. And of their general formula, it is M stands for metal, any metal in alkali group, M2O. So So for example, lithium is in that alkali metal group, so that's Li2O, Na2O, K2O, Rb2O, Cs2O, and Fr2O. Now, when you write for chlorides, for alkali earth metals, no, it's for, yeah, alkali earth metals. When you write, the general formula I'm going to write is MCl2. MCl2. So, for example, if it is Ba, then we can have BaCl2, CaCl2. So that's how you can write their general formulas. So each families, they have similar chemical properties.